My name is Leanne. I've been working for the City Council for about 11 years, straight out of varsity, and I did my master's there in microbiology, and now I've been working here as the drinking water scientist, checking drinking water quality.
Karel Taljaard, agricultural engineer, worked in the water sector for most of my life, past 20 years for City of Tshwane, last 10 years managing the plant. Rietvlei was built in 1932. The plant was built in 1934. The dam is part of City of Tshwane, specifically built for water purification to the city. And during the years it was upgraded a couple of times. The last time it was upgraded in 1999 when we add the granular activated carbon. And currently there's some construction going on for the construction of ozone to the plant. The Rietvlei Dam has a capacity of 12 million cubic meters. We purify 40 megalitres per day on a continuous basis. Production of the plant is in the region of 37 to 38 megalitres per day. Water quality is exceptionally good. The catchment area is about 400 square kilometers. Most of the water is coming from the Kempton Park area. The Rietvlei sewage works is contributing to the dam with their effluent water. The dam is classed as a Category 3 dam. And it's got a high risk potential because of where it's situated, and that there's some highways and people living downstream of the dam.
If the quality of the effluent is fairly good, then the risks are fairly low. Obviously, it's a question of how much you monitor as well. But because we've got a dam that's highly eutrophic, that means that it's got a lot of nutrients in it. We have quite a lot of problems with algal growth, specifically blue-green algae, and that causes a lot of issues when we come to tastes and odors, and these blue-green algae even produce toxins, so that is also a health risk and a health concern for the tap water. Our first priority is a long-term thing. It's called catchment management, and I'm sure most people know about that, but it's not the easiest thing to implement, and it is a long-term project. So we talk regularly to the Hartbeespoort Fontaine sewage treatment plant, and they actually warn us if there's problems there. Then we also have sample points upstream of the dam, and we have sample points in the dam, and then we start monitoring as we go through the process after every critical control point. Our biggest problems are probably the algae. When we're talking about blue-green algae, they can regulate their buoyancy. So at a certain stage of the day, they move past the draw-off point, and when they do that, we have trouble. And then the turbidity jumps from like 1 point something to 20 or 30 turbidity units, which causes havoc with the treatment process. Another problem that we've experienced once or twice is when we have a severe flood, then we get high turbidity water, and the plant is not normally geared to high turbidity water with particulate matter. So then it's a bit of a shock for the system. The solar bees are high-powered reservoir circulators. They basically work on a very simple principle of just lifting the water a small amount, a small height, just a little bit, and pushing the water out. So it sucks it up from a certain depth wherever you set the solar bee hose, and it sucks it up the hose and it lets it flow out on the top, causing it almost like a laminar flow. And due to this, it causes the water to start circulating, and by doing that we are disturbing the habitat of the blue-green algae. This is a first for South Africa. It has been used with lots of success in America and Australia and several other places, but this is the first time it's been done in Africa. The Rietvlei Dam is a COT, a City of Tshwane owned dam, and it's a small dam. It's fairly well controlled, so we can put these things in and make sure that they tend to stay there. And we have a lot of data on this dam. We've got data going back for 20 or 30 years. So because of that fact, it makes it easier to compare before and after.
The dam's got a draw-off tower. We're lucky enough that we've got three different draw-off points. We can change the draw-off point to see where's the best quality of water. From the draw-off point, it's coming into the plant. First, we add lime for pH correction purposes. Thereafter, we add a coagulant, which can vary depending on the water quality through the year and what is the best at that stage. From the dosing point, it's going through the flock channels, giving us a 10 minutes contact time through the flock channels for the flock to grow. Once it's through the flock channels, it's into the DAF filters. We've got dissolved air flotation and filtration filters, meaning that we've got two processes combined in one filter box. The water is entering the filter behind a weir. As it enters, we also add saturated air-water mix to the water. The air bubbles is actually lifting all the impurities that wants to float. The heavier impurities in the water, the heavier flocks, will settle down at the filters, and from there it's a normal sand filter. The sand filters is made up of various grades of gravel and sand, as well as some anthracite to give us a bigger surface area to catch the impurities that's still in the water. From the DAF outlet box, it's going through a screw pump, a Archimedean screw pump. It's lifted to the GAC filters. The reason for the pump is just to gain enough height to get it through the GAC filters. The GAC filters is granular activated carbon. The main aim of the filters is to remove taste and odors, which is associated with the blue-green algae. From the granular activated carbon filters, it is going into the reservoir. Just before entering the reservoir, we're doing the disinfection. At this stage, it's done with chlorine gas. From there, it's pumped to two reception reservoirs, where it's blended with rainwater at this stage.
We have catchment management samples, so we do samples on the raw water in the dam. We also do samples right through the process. After we get the raw water in, after it goes through the DAF process, after it goes through the GAC, and then once it's chlorinated, we also take a sample. These we monitor for the constituents as mentioned in the SANS 241, the South African National Drinking Water Standard. We also then monitor the water from the final water all the way through. After the reservoirs we monitor, we have network points and point of use, actual consumers who give us samples from their house. So we get a complete picture from catchment to consumer, which is what the World Health Organization and everybody who knows anything about water and wants us to do, is from catchment to consumer. The purpose of the online meters is to give us a better feel of what's happening on a continuous basis. The pH meter on the raw water, we have a turbidity meter on the raw water. That's also to monitor if we have a sudden increase in algal mass, that we'll be able to pick it up early before it hits the filters. Each filter also has a online turbidity meter, and that's basically to monitor the filter performance and also to check that our dosage is correct. So in other words, when we start seeing that there's an increase in the turbidity of the filter effluent, we know that we need to we've actually got a standard operating procedure in place there. So the operator will know that they need to take steps when they see that the filter effluent is rising. And then we've also got a chlorine meter on the final. We monitor that chlorine on a continuous basis. Obviously, that's one of the most serious places that we need to monitor to check that the chlorine is sufficient.
It can differ. At Rietvlei we don't have settling tanks, for instance, which is more common on traditional purification plants. Because of the fact that we've got a lot of algae and they're fairly light and they want to float, well, many years ago they opted for the option to use the flotation process. The granular activated carbon was the first plant in South Africa that introduces that. It is a very good practice at this stage. It proved to be very successful, and we have it is still a very good practice, although it was not initially intended for that, to help us with the endocrine disrupting chemicals. That is also a problem for most of the dams in South Africa, but also for Rietvlei. For the other procedures, most of it is standard sand filters. The type of chemicals used can vary quite a lot. The process of coagulating the water, getting flux in the water can vary from place to place and from types of waters that have to be treated. Disinfection can vary, but most common is chlorine dosing to disinfect water. Rietvlei is fortunate in the sense that it's close to the big cities. It's a fairly small plant, fairly compacted. So there's a lot of universities in the surrounding areas in Joburg and Pretoria. So there's a lot of the academics that would like to be involved with Rietvlei. And I think they help a lot in selecting processes. Professor Johannes Haroff from the University of Joburg at this stage played a major role in processes that was introduced to the plant. And then I think I must just mention that our previous boss, Piet Cronje, was also open-minded to accept these new approaches. I can just mention that the DAF filtration process was also a first in South Africa, as well as a granular activated carbon process.
This time around we are not the first with ozone in South Africa. Ozone's been used a lot overseas especially, and in this particular instance we're going to be using it for breaking down the organic compounds, the very complex organic molecules that we find between the DAF process and the GAC process. So basically it's going to be able to help us break down those organic molecules so that the GAC beds will work more effectively than before, and also to improve the biological activity on the GAC beds. Basically those compounds are complex organic molecules. They're actually too complex for our limited lab anyway to be able to determine exactly what they are. But there's just the total organic carbon is easily removed in the DAF process. The easily removed TOC is removed in the DAF process, but the more complex, harder to degrade compounds have to go through the GAC. So we feel that by breaking them up into smaller bits, we'll be able to get rid of them much easier. I think every water purification plant should have a lab. It's a question of how big the lab should be. We are lucky, I guess, because we've got a fairly well-equipped lab. We've been very lucky. We've been able to get very good equipment, and we're basically fully kitted out for, or mostly, I'd say about 90% kitted out for the SANS 241 drinking water specifications, all the analyses that we need to do for that. Most water treatment plants have basic things that they do on the works themselves, and the operators are generally responsible for that. That's like pH and turbidity and chlorine residuals and color. But what the big advantage is for Rietvlei is that if there's a problem, it's attended to the same day. It's not a question of take the sample and wait another 2 weeks. That's the nice thing about Rietvlei. The Rietvlei lab is situated here. We do a lot of work on the Rietvlei lab, but we also do a lot of work on the drinking water in Tshwane. So we not only look at the process here, but we also look at the final quality to the consumer, and also the other treatment works that impact on City of Tshwane's drinking water. The Rietvlei water treatment plant produces about 6% of the City of Tshwane's drinking water requirements. The remainder of the water the bulk of it is about Rand water, it's about 70%. And then there's about 100 megalitres of water a day that's from our own water sources. That's Rietvlei included. And then we have 2 other water treatment plants that produce water for us, but are managed by Magali's Water.
Process controllers is 5 at this stage, plus a senior process controller, and then with the process controllers there's 2 shift workers, or 8 shift workers actually, because one of the process controllers is doing the outstations. So there's 8 shift workers with the process controller. So per shift, 3 people on the plant, 1 process controller, 2 general workers with the senior process controller. Plant is run 24 hours per day, 7 days a week throughout the year. Our requirements is that they must have a tertiary qualification in water and wastewater purification. We employ people with a Class 3 Water Affairs certificate, or we aim for that, Class 3 or higher. Once a year, we would like to add training to it. At this stage, the training that's compulsory for them is safe handling of chlorine, which is a very important part of the plant and a very dangerous type of operation, so it's very important that we do that. I think we were fairly lucky at Rietvlei up to now that we've got good process operators. It is very important that a process controller must be aware of what's happening around him, wake up that he wants to check the processes, see that dosing is done correctly, see that the water, final water quality is good, talk to other people and make sure that in general the water is of a good quality, because it's impacting on the public's health directly. So it's a very important process. Yes. New designs on the plant, major designs, is conducted by consultants. The construction, obviously, also bigger contractors that's appointed to do that. Small designs like a small little pump or a pipe or so on, we can do in-house, but all the major improvements is done by consultants. Occupational health and safety is quite a huge part of running a plant like this, very important. To me, one of the most important parts of the plant. There's safety towards the water that we purify, but the people working on the plant, that occupational health and safety is first priority, in my opinion. We've got regular meetings with health and safety officials working within Tshwane. There is also accreditation done by the Department of Labour at the States. They've been here, and we were lucky that we came off fairly well after their visit. There's safety reps appointed at various points, regular training for body aid training and first aid.
We do outsource some of our tests. Some of them are just not feasible to do in a lab like this. That's like viruses. There's only one lab who can actually do it. So we send our viruses there. And the Cryptosporidium and Giardia's protozoan parasites, we send those to an accredited facility. And it's actually Randwater does it for us because they're internationally accredited for that method. Once a year I will take a couple of samples and send it to an external lab, an accredited external lab for verification purposes. We also do proficiency testing. So every month we get samples from independent that we analyze and we send it back, and then we compare our results to those of other labs. And that's both for the chemistry and the microbiology. When we started looking at something to help us with the raw water quality, we had a look at a lot of different alternatives. There's a lot of things on the market that claim to be good. Whether they're good or not is another point. But we decided to try this because it has been done in several other lakes that have been used for drinking water quality. So those people have got quite a lot of knowledge as a solar bee in America. And they actually helped us a lot with the sites, how to space the solar bees, how far apart we need to put them. They're about 450 meters apart. And they had a look at the bathymetric maps of the dam to enable us to make sure that they're spaced in the correct way. And then the first 6 were put in the area where the algae grows the most, and then later on when we got the other 10, we placed them in the rest of the dam. So this is the largest dam with full-scale treatment in the world. The solar bee is a patented piece of equipment that comes solely from America. So there's no South African involvement apart from the fact that we're the first guinea pigs as such. It's a long-term process. We've had it in for 2 years now, and I think that now we can start seeing a difference. there's a lot of factors involved because we've had a lot of rainfall this last year. So it could be the rainfall, or it could be the solar bees. However, comparing it to other dams in the area, the other dams are not doing as well as Rietvlei. We're doing a lot of tests. I go out on the dam at least once a month, and in summer I go out twice a month to draw samples at different depths, and I do temperature profiles and Secchi disc and all kinds of interesting, weird and wonderful stuff to monitor the algae and to monitor the condition of the dam. So hopefully by using the before and after we'll be able to see if it's really working or not.
The award was awarded to the most presentable medium-sized plant in the country, meaning that it's well maintained, neat, clean and efficient. The people that did the adjudication for that was guys from the UK, two separate people, so we won it twice, and so we hope that we can carry on with it, just doing our work as we're supposed to do, and we're very thankful for the recognition of achieving that.
Blue Drop was a program that was initiated by the Department of Water Affairs. I think they started working on it in about 2008 because they realized that they weren't getting information on drinking water. Blue Drop is for drinking water regulation, and they weren't getting enough information on the quality of drinking water coming out of the tap. So they started this initiative, and it grew and grew to become Blue Drop, which is basically a list of regulations that they, or not regulations, but a list of things that they come to audit you on. So it's everything from drinking water quality to asset management to process controllers to publication of drinking water quality performance. It's all these things and more. It's about managing your drinking water with excellence. To win Blue Drop status is quite an achievement by any standards, because you only get a Blue Drop if you're above 95%. So there's a whole lot of municipalities that are being audited by internal and external people from from the Department of Water Affairs, from the United Kingdom. There's an agreement between the United Kingdom and the Department of Water Affairs to run this system, and they come out and they do check all your aspects of drinking water quality management. So by doing that, the consumer knows that that municipality or that system that has been awarded Blue Drop means that they are doing it right, and that even if something goes wrong, that we know how to react. So it's just to give the consumer public confidence in drinking water. There were over 700 systems that were assessed in this last 2010 year, and of them 13% got above 90%, and you only get Blue Drop when you get above 95%. So I think there were 26 Blue Drops this last year. That we can attribute the Blue Drop status to maintenance issues. We have a lot of good routine maintenance. We have routine maintenance and non-routine maintenance, and we also have a lot of procedures in place already. The big challenge with Blue Drop is to get all the knowledge that's in your head onto the paper, and to get all the team players involved, because not all the members of the team are sitting at Rietvlei water treatment plant. Carl and I are lucky because we sit very close together, and a lot of what we do is all about Blue Drop. But there's a lot of other things when it comes to asset management and financial management, we need to include those people from other areas. And to get the right team in place, to get them committed, and to get them writing down what they know is really important.
The Blue Drop assessment is gradually increasing in the intensity and difficulty. The first round, we were lucky enough that a lot of that stuff was in place, and not in the format that they would like it to be, but that the basic data was available. The past year we had to put that together in a different format and get it going, and that helped a little bit that we had to do that. We also had to include other role players that's not on the plant and in the lab, because it's actually increasing what the requirements is. So yes, there was a couple of meetings. It is a process of getting everybody on board to do that and to get their knowledge on paper, as Leanne said. But I think at the end of the day, if your attitude is that you can gain something from it, it is working. And although in the beginning we were all skeptical, especially myself, I can see that it is gaining momentum and that it probably will help the country now.
I think there's obviously scope, because there's so many facets of treatment of water in all its forms that I think we shouldn't be blinded by what we already know, but obviously look at new things and try them out. So I do think there's scope for doing things a little bit more naturally and organically and ecologically sound.
Rietvlei, the nature conservation part, that's part of the farm on which the plant is built, is actually well maintained, well managed. The dam is well managed. There's no motorboating allowed on the dam. So I think we're very fortunate in that sense that the water quality is that there's not a lot of pollution impacting on the plant from external sources apart from what is running downstream. That there's a couple of challenges from farming and fertilizing the soil and so on. But at the dam itself, we're very fortunate that it's well maintained. Yes, there is possibilities of increasing the capacity if we get more water from sources outside of this catchment area. For the catchment as it is now, I think we're sort of limited to our maximum capacity, and we're fairly fortunate that we can run on basically maximum capacity at all times.
I think we probably do have a water crisis. The reason why we got there, that's a very long, complicated question, but it's probably due to mismanagement, to people who aren't properly trained or don't really know the impact. It's probably due to poor catchment management. It's probably due to irresponsible manufacturers that pollute water sources. Or mines that aren't properly regulated and controlled. How do we get out of it? It's going to be a long journey to get out of that one. I think we're probably heading in the right direction now. I know that there's the Green Drop initiative by the Department of Water Affairs will help a lot, but it will be a long and hard road to climb out of the mess that we find ourselves in. I think the one thing that we really need in this country as a whole, and I from what I see in the water sector, is that the political boundaries, the boundaries of the towns and the cities are not always the water boundaries. And the communication is lacking between the authorities running the city or the towns and the actual water moving through them. if the authorities could speak to each other more and talk to each other more about the water going through them, then I think we'd be a lot better off.
With regards to water, I think South Africa is fortunate that the quality of educated people is fairly high. There's still some expertise available, although it seems as though that is becoming less as we carry on, and there's some big concerns about people leaving the country with necessary knowledge. I think, if I can speak from Rietvlei point of view, we need attitude. I think attitude is extremely important on all plants, and we must educate people about the importance of good quality drinking water and what the impact is if your water is contaminated, and what the health impact will be. From time to time we get visitors from other African countries. I think they learn a lot from us. They're very eager to learn. I think if the politics in those countries are run as they're supposed to be, and people start noticing what the importance of good quality drinking water is, it can be done. The attitude is very important, that they must be willing to do that, but I'm pretty sure it can be done. I suppose South Africa and experts in South Africa can still contribute quite a lot to those countries by advice, work that can be done there. I think there's still a lot of knowledgeable people in the country that can also help some of the municipalities that's struggling at this stage to achieve blue drop status, to better their water quality, if they are allowed to do that.
I kind of hope that Rietvlei will carry on winning the awards that we've won. For the city of Tshwane, with regards to blue drop status, we want to get better and better. I'm pretty sure that we'll probably get an increase in our score. That's what we're aiming for every year. With regards to the green drop, I know that we're busy on the green drop issues, and that management is aware of it and keen to fix things that are lacking. With regards to water in general, it really depends on who's running it.
I think South Africa as a whole can look at various options of using water, and I think the public must be made aware of how you can use water. Grey water can be used for flushing toilets and those things. If computers could have developed to where it is today, the water sector can develop with that as well, and water can be used twice perhaps, or even more, and in that sense we can get away probably with less water if people just managing it better.
In Australia they've got a rebate system for rainwater harvesting and the reuse of grey water. And I think that's something that we should seriously look at, because we're also a water scarce country. So it makes sense to do that kind of thing. I'd like to think that the water community in general is quite closely connected and very open to discussion. I've had lots of I've learned a lot through picking up the telephone and phoning somebody and saying, listen, I need some help here. So I've got quite a lot of people that I know that are experts in their field that I can contact when I need help. And that makes a big difference. I think no matter where you are and what you're doing and whatever level of training you have, it's always nice to have somebody to confirm your suspicions. I know that the engineers are few and far between, and the scientists probably even fewer. It's not a field that somehow gets a lot of graduates. I know that there have been programs in place. I know ECSA has done a whole lot of work on trying to encourage people to walk into the water field and into the engineering sector as well. But there's not a lot of new kids on the block at the moment.
I think if we want to increase the quality of drinking water and treatment of wastewater in general, politicians must play a big role in it, to allow people to do the work without putting in constraints to get those people out of the business. You want everybody that knows the work to be in that field and to contribute as much as possible back into that field. And I think it's very important that politics must stay out of it. There's a lot of infrastructure in the country that can be better maintained. And I think it's very important to put in processes and practices to do preventative maintenance, to maintain things. You can't run a car with flat tires. And I think that in many cases the infrastructure was there. It must be run properly. It must be maintained. And I think a huge problem in the country is that the maintenance part is lacking. And we must be careful not to redesign and change the plant, but rather keep that what's there in place until there's enough money or resources available to upgrade it. But probably a lot of plants can, by good maintenance, speed up their production and quality.
First, you're going to have to prove that it was the tap water, and that is hard enough. So it's easy if it's something like a protozoan parasite that they can isolate from your body and prove that it's a parasite that can come from drinking water. But you have to, there's so many, water is normally not the only thing that carries those particular things. So you're going to have to isolate everything else. It's very difficult to actually trace it back. Unless you can prove there was a failure in the plant, and then you look at maintenance records and you look at operational records. And if that's missing, how do you know? You won't know. It doesn't help you take a final water sample the day after you put your chlorine cylinder in, you let it run empty, and then 2 months later you buy another chlorine cylinder and take another sample. Then the water's going to look good, but it's not. You see, normally the Department of Water Affairs will issue a directive to say, clean up your act. But a directive, I see now one particular municipality's had a directive for like 18 months and they've done nothing in the meantime. So it actually means that politician should land in jail. The mayor or the SED or whatever should land in jail for that. That it becomes a real big hard stick, because otherwise you're not going to get it right. It's just not going to work. Home treatment devices are not necessary if you live in the city of Tshwane. It's not necessary if you live in any kind of metro that's got a blue drop status. I would not buy it. I think it's a waste of money. With regards to what they do, yes, they do purify the water to a certain extent. The question is, why do you want to purify it to that level? It doesn't help you purify it to battery water level and then you take in a multivitamin. It's a bit silly to me. With regards to bottled water, I would suggest bottled water is mainly for convenience. It's got a very high carbon footprint, and if you're not buying from a reputable supplier, then the quality can be questionable sometimes, especially if it's been on the shelf for a long time. So if you're going to have to buy bottled water, then I'd say buy bottled water that comes from a bottler who's registered with the South African National Bottled Water Association. But in Tshwane, fill your bottle at the tap.